songs sound the same lately, like upbeat, dancey, happy vibe, and they all go viral. Hi, I'm the CEO of Spotify. Here's the situation. We spend millions on promoting songs, but how do we know which songs to push? Because if we get it wrong, we miss hits, we waste money, and users leave. But what if we just analyze how songs sound? Danceability, energy, balance. If we find a pattern and we scale it, this could change everything. Or we test it.
Hi, I'm Hao Ting from the Spotify Analytics team. We were asked by our CEO to investigate whether it is possible to predict which songs will become hits based only on audio features. This question is important because if audio features are predictive, Spotify could promote potential songs earlier, leading to a first mover advantage and thus gaining more users. To answer this, we applied a structured statistical approach to test the relationship between how a song sounds and how popular it becomes. We worked with two datasets. The first includes 50,000 synthetic Spotify tracks and represents general music on the platform. The second includes the top 100 songs and represents successful hits. We define popularity score as the dependent variable, and then audio features such as danceability, energy, valence, acousticness, and tempo were used as independent variables. These features describe measurable characteristics of songs and allow us to apply statistical methods. We formulated our hypothesis in statistical terms. The null hypothesis states that audio features have no relationship with popularity. The alternative hypothesis states that at least one feature has a significant relationship with popularity. This allows us to evaluate the relationship using statistical evidence rather than intuition. We started with an exploratory comparison between general songs and hit songs. The goal was to check whether successful songs have distinct audio characteristics. If audio features influence success, we would expect to see clear differences between these two groups. We use box plots to compare the distributions of audio features. As we can see, the medians are very similar across both datasets, and distributions overlap significantly. There is no visible separation between general songs and hit songs based on these features except for acousticness, where its median and overall distribution for the top 100 songs are quite a bit lower than the general songs. This suggests that only the acousticness of a song might influence its popularity. We then compared the average values to quantify these differences. Most features show nearly identical mean values. Acousticness is also lower here in the top 100 songs, but other features do not show any consistent pattern. This confirms that differences are minimal at the aggregate value. The visual and numerical results thus lead to the same conclusion. Since the feature distributions overlap and average values are similar, there is thus no consistent pattern that separates hit songs from typical songs. Then applied Pearson correlation to test linear relationships between audio features and popularity. All correlation values between popularity and audio features are close to zero. This indicates that changes in audio features are not associated with changes in popularity. The data thus does not support a statistical relationship. We then applied linear regression to test combined effects. The model has an adjusted R-squared close to zero, and the p-value is too high and therefore not significant. This means that the model cannot explain variation in popularity. We also analyzed relationship between features and found strong correlations. Energy is strongly related to acousticness, danceability is strongly related to valence, and energy is also related to tempo. These relationships show that features are not independent. So, the model fails due to the multicollinearity. Audio features overlap and capture similar information about the song. So this makes it difficult for the model to isolate the effect of individual variables. As a result, coefficients become unreliable and the model loses its predictive ability.
These findings have direct Implications for Spotify. Audio features provided useful description of music but do not explain popularity. Decisions based on only audio data are not reliable. Better prediction require behavior and contextual data, including user engagement, placement, artist research, and marketing activity. So we went into this expecting to find a pattern in the music itself. Instead, what we found is that hit songs don't follow a consistent audio formula. Across all our analysis, songs that succeed do look fundamentally different from those that have. This means the answer is not in the sound. From the data, success is shaped by how songs are distributed, discovered, and engaged by with by listeners. So if the goal is to identify future hits earlier, the focus should shift toward user behavior and platform dynamics. This includes early listener signals such as streaming growth, skip rates, replay patterns, and how quickly a track gains traction across the playlist. That's the direction we would recommend moving forward.
Okay, so I was wrong, but it actually saves us money. Instead of guessing based on sound, we should focus on like user behavior and engagement data and real world signals. Because hits are not engineered, they are discovered.